In this video, we're going to discuss absolute value functions. An absolute value function is y or f of x equal to the absolute value of any variable, or y is equal to the absolute value of any variable plus or minus something, y is equal to negative the absolute value of some variable plus or minus something, or y is equal to negative the absolute value of x plus 4 minus 2. Let's graph some of these on the calculator and see how they look. Let's graph y is equal to the absolute value of x. To get the absolute value side, we can do alpha. And if you notice when the alpha button is not pressed, it's green. That means that when we do press it, we activate the little green letters or little green words above each of the buttons. So when we press alpha window, we're going to the F2 menu. And then the first number 1 is ABS, which stands for absolute value. And press enter. Now we have our absolute value bars, and inside we're going to type in x. And then we'll use zoom 6, zoom standard to graph it. So that's what a very basic absolute value function looks like. It looks pretty much like a V. Let's graph another one. Let's graph y is equal to the absolute value of x plus 4. So alpha F2 again. Absolute value of x plus 4. And zoom 6 for zoom standard. So now since we added the 4 inside, we just shifted our graph over to the left a little bit. 4 units to the left. Our graph now looks like that. Let's graph the next one. Y is equal to negative the absolute value of x plus 4. And zoom 6. By putting the negative before the absolute value sign, we reflected this graph over the x-axis. So it now looks like that. And let's just do the last one. We have the same thing, negative the absolute value of x plus 4 minus 2, and zoom 6. Now we moved the one that was reflected and shifted over to the left. We moved it down 2. So it looks like this. You might be asked on the Regent for the minimum or maximum of an absolute value function. If you're given a graph or an equation that you can graph, it's very easy to find the minimum or maximum. If you're given a graph and you could see very easily, you'll be given grid lines, obviously. You can usually see very easily, like say this graph would have a minimum at 4, 3. Or if you're given a graph like this, you'll see very easily that this graph has a maximum at 2, negative 2. If you're not given a graph, let's say you're given an equation, y is equal to the absolute value of x plus 4 minus 2. You can either graph it on your calculator. Let's graph y is equal to the absolute value of x plus 4 minus 2. Alpha window, enter, x plus 4, and then minus 2, and zoom 6 for zoom standard. So that's the graph, and we could see that the minimum value is right over here. But how do we know the exact coordinates? We could have the calculator tell us. So we see it's a minimum. If you press the second button, when you press the second button, notice when it's not clicked, it's in blue. That means whenever you click a button, you're really activating the little blue words. When you press the second button, you're really activating the little blue words above each button. So when you press trace, you're in the calc menu. And you can scroll down to minimum and press enter. Now, of course, if your graph would have a maximum, if your graph looked like this graph over here, now in red, you would use the maximum command, which is the 4, but we're using 3, which is minimum. Press enter. And the calculator wants you to tell it where is the left bound. Left bound just means go somewhere to the left of where you think it is. It's very obvious where it is, so just go anywhere to the left of it. Bring your little cursor anywhere to the left. And press enter. Now the calculator wants the right bound, so you have to bring your little cursor to anywhere to the right of the minimum. And press enter. And now the calculator wants you to guess, so go to where you think it is. It's very obvious in this case where it is. And press enter. And the calculator calculates for us the exact coordinates. The calculator tells us that the minimum of this graph is 4.00002, And the calculator has a little bit of a rounding error usually when finding zeros, minimum or maximum of any graph, and it's correct to say that the answer is -4, not 4.00002. And in fact, if you would write on the region 4.00002, you'd probably get it wrong because on the region and really wanting to realize that the calculator has made a bit of a rounding error and it's really -4. And the same thing is true for the y-coordinate, 1.9999998. It's so close to 2, there are so many 9s there, it's so close to 2 that they want you to realize that it's -2. The minimum of this graph would be -4, -2. Another thing you want to know is that all absolute value functions are in the form y is equal to the absolute value of x minus h plus k, where h comma k is the vertex, either the minimum or the maximum. So let's say we have an equation, y is equal to the absolute value of x minus 4 plus 1. You would know automatically the vertex is 4 comma 1. Let's say you had the function y is equal to the absolute value of x plus 4 plus 1. Then, since in the original equation we have a minus sign between the x and the h, we have minus h, and here we have a plus sign. When we're writing out the vertex, we have to switch the sign. So this becomes -4 comma positive 1. And let's say we had the function y is equal to the absolute value of x minus 4 minus 1. Since normally our k is plus k, and here it's a -1, we have to switch that sign when we're writing out the vertex. In this case, we did not have to switch the h value because we have a -4, so it becomes 4 comma. We have to switch our k value, so instead of being positive 1, it's -1. And that would be the vertex of this one. Another thing you might be asked about absolute value functions is the domain and the range. What is the domain and what is the range of an absolute value function? Domain, you might remember, are all x values that the function will ever take on. And range are all y values the function will ever take on. So let's say we had a very basic absolute value function, y is equal to the absolute value of x. The easiest way to find the domain and the range is to graph it on your calculator and see what are all of the x values that this graph will ever take on, and what are all the y values. So we're going to do alpha f2 and enter, then x, and zoom 6 for zoom standard. Let's first look at the domain. We see that this graph, it goes on forever and ever. It keeps on going out past the screen. It keeps on going on and on and on to the negative x's. It keeps on going on and on and on and on in the positive x's. So the domain is all real numbers. We're going to have negative numbers, 0, positive numbers. Keeps on going on forever. The range, however, notice that we have no y values in the third quadrant and in the fourth quadrant, and we never will. We're never going to go below the x-axis for this graph. So the range is all y values that are greater than or equal to 0. Let's look at another one. Say we have the function y is equal to negative the absolute value of x minus 4 plus 2. Now this function has a lot going on. To find the domain and the range, the easiest way to do that is to just graph the whole thing on the calculator. So y equals, let's clear out the old one, negative alpha window, or f2 to get the absolute value sign, x minus 4, then we'll go to the right to get out of it, plus 2, and zoom 6 or zoom standard. And we see that our graph is reflected over the x-axis and shifted 2 units up and moved 4 units to the right. So the domain of this function, we'll notice that the x values, this graph keeps on going on and on and on in the negative x direction, and it keeps on going on and on and on in the positive x direction. So the domain is still going to be all real numbers. The range, however, we notice that we're never going to go above whatever this maximum point is. We're going to have all y values that are less than or equal to whatever the y value of this maximum point is. But we don't know what the maximum point is. Either, if you remember that all absolute value functions are in the form y is equal to the absolute value of x minus h plus k. If you remember that h comma k is always the vertex, then in this case the vertex would be 4 comma 2, and the maximum y value would be positive 2, so y is less than or equal to positive 2. If you did not remember that, you could go second calc, or trace, you're in the calc menu, and scroll down to maximum and find the maximum. And you would get the same thing, 4 comma 2. Another thing you might be asked about absolute value functions is where is the graph increasing and where is the graph decreasing. Once again, the easiest way to do this is by graphing it on your calculator. And let's go back to this function that we had already graphed, y is equal to negative the absolute value of x minus 4 plus 2. We already have it graphed, so let's look at the graph. We want to know where is it increasing and where is it decreasing. So it's increasing from wherever the minimum x is, which is negative infinity, until we get to the maximum point. The maximum point we know is 4 comma 2. So that means that this graph is increasing from negative infinity until the x-coordinate of the maximum, which is positive 4. And then after it reaches this maximum point, it decreases until x is equal to positive infinity. So it is decreasing from x is equal to 4 until infinity. One more thing you might be asked is to graph an absolute value function. Let's say we're asked to graph the function y is equal to the absolute value of x minus 4. To do that, we need to find x and y values, points to plug in. To do that, we're going to make a table. This will be our x column, this will be our y column, and the absolute value of x minus 4 is equal to y. So we need to pick arbitrary x values that we're going to plug in and solve for the corresponding y values. It's usually safe to pick x values negative 2, negative 1, 0, 1, and 2. That way you have some negative numbers, some positive numbers, and 0. Let's solve it using these points. So for x, wherever we see an x, we're going to plug in negative 2. We have negative minus 4 in absolute value. So minus 2 minus 4 is negative 6. The absolute value of negative 6 is positive 6. Next, we have negative 1 minus 4. Minus 1 minus 4 is negative 5. The absolute value of negative 5 is positive 5. Next, we have 0 minus 4. 0 minus 4 is negative 4. The absolute value of negative 4 is positive 4. Then we have 1 minus 4. 1 minus 4 is negative 3. The absolute value of negative 3 is positive 3. 2 minus 4 is negative 2. The absolute value of negative 2 is positive 2. So let's graph these coordinates. Negative 2 comma positive 6. Negative 1 comma 5. 0 comma 4. 1 comma 3. 2 comma 2. Now notice we only have 1/2 of our v. We only have the left side of the v. So we're going to have to keep on going and plug in more positive x's to get the other half. So let's plug in 3, 4, 5, and 6. 3 minus 4 is negative 1. Absolute value of negative 1 is positive 1. 4 minus 4 is 0. The absolute value of 0 is 0. 5 minus 4 is 1. The absolute value of 1 is 1. And 6 minus 4 is 2. The absolute value of 2 is 2. Let's plot these points. We have 3 comma 1. 4 comma 0. 5 comma 1. And 6 comma 2. Now we could keep going and plot more points. You could do it on your own if you want. But this is enough to give us a good picture of what this graph will look like, something like that. And we could see that our vertex is at 4 comma 0. And we expected that because all absolute value functions are in the form of y is equal to the absolute value of x minus h plus k. In this case, k would be 0. We could have just plus 0. So we knew that our vertex would be at 4 comma 0. Let's say you didn't want to go through the effort of actually plugging in all the points like that. What you could have also done is gone to your calculator and graphed this. The absolute value of x minus 4, and then done zoom 6, and you would see the graph. How does this really help you? If you press the second button and press graph to go into the table, then you could see this table that we just drew. You can scroll up and down to see all of the x values and their corresponding y values.